The story is almost perfectly designed for the internet. An illuminated luxury tower forced to rely on a daily convoy of sewage trucks just to remain habitable. It makes the ultimate architectural icon look foolish. It is a story shared millions of times across social media platforms. But the most famous engineering failure in Dubai is probably wrong. Original mechanical engineering documentation for the project describes a complete soil, waste, and vent system. It was designed to discharge through gravity flow and ejector systems toward a direct point of connection with the municipal sewer. The viral story survives because it is far more entertaining than plumbing diagrams. But relying on an absurd internet myth actually hides a much more disturbing reality. The real maintenance trap is not a forgotten sewer connection. The real trap is what it actually takes to keep an 828-meter tower looking effortless. Look closely at the exterior of Burj Khalifa. From a distance, it appears to be one continuous, flawless silver surface. But that appearance of perfection is an illusion created by tens of thousands of individual obligations. The facade uses close to 26,000 individual glass panels. Each panel weighs approximately 362 kilograms. Every single piece of that massive aluminium and glass exterior had to be individually cut, precisely sealed, and carefully installed to reach a historic record height. That massive surface does not naturally remain immaculate when exposed to high-altitude wind and desert dust. Flawlessness is a highly coordinated operation. To clean the entire exterior, maintenance crews rely on a specialized network of track-mounted systems and manned cradles. Reaching the complete surface normally requires approximately 3 to 4 months of continuous vertical labor. The implication is staggering. The moment the cleaning cycle is completed, the tower is essentially demanding another rotation. The exterior is not simply built and left alone. It must be physically recreated by human hands and specialized access equipment 4 times a year, every single year. The glass, the aluminium framing, the complex seals, the protective coatings, and the access systems themselves all belong to a permanent facade management clock. The building must remain fully occupied, the luxury image must remain intact, and hospitality operations cannot stop while this exterior work takes place. Maintenance must constantly coordinate with the visual expectations of premium residents, corporate tenants, and global visitors who expect nothing less than absolute perfection. The financial cost of this constant aesthetic upkeep is tightly woven into the operational budget. This is the first reality of the maintenance trap. Appearance is a critical, never-ending operational burden. But keeping the outside clean is useless if the people inside cannot move. The next maintenance clock is far more critical than visual perfection. Without it, extreme height stops being a luxury attraction and instantly becomes a physical obstacle. In an ordinary low-rise building, an elevator is a convenience. Inside a vertical city extending over 800 meters into the sky, vertical transportation is the building's central circulatory system. Without these mechanical arteries, the entire structure is essentially uninhabitable. A premium residence or a corporate office has absolutely zero economic value if people cannot reach it reliably. Burj Khalifa relies on 57 lifts and 8 escalators to move thousands of occupants through its pressure zones every day. In 2024, that original circulatory system entered a completely new phase. Otis announced a massive modernization program for 34 of those elevators and all 8 escalators. The agreement includes upgraded monitoring technology, advanced control systems, and another 10 years of continuous service. When a modernization program of this scale is announced, the immediate assumption is that the original system must have been failing. That assumption is completely wrong. Large, heavily used buildings routinely modernize their elevators as control technology and operational expectations evolve over a decade of use. Modernization does not prove that 34 elevators suddenly became unsafe. But it does reveal exactly what normal maintenance becomes when applied to a supertall mega project. The elevators did not become evidence of an engineering disaster. They became evidence that the tower had entered its permanent upgrade era. This transition creates an enormous logistical challenge. Old and new generations of equipment must temporarily coexist within the same shafts. Equipment must remain safely available while adjacent systems are systematically taken offline for upgrades. Specialized technicians, historically described as being available around the clock, must integrate new interfaces with existing infrastructure. Disruption must be strictly minimized while the vertical city continues to function around them. Normal modernization at this scale transforms into a highly complex industrial process. The residents never see this friction, but the elevators are only one moving part in a much larger machine. To keep those visible spaces functioning, the tower relies on an entirely separate building hidden inside its own walls. Guests and residents only experience the architectural building. They see the marble lobbies, the premium hotel rooms, the corporate suites, and the observation decks. They do not see the 7 double-height mechanical floors strategically distributed throughout the structure. These dedicated, highly secured zones are absolutely not wasted real estate. They operate constantly to regulate the internal climate against the extreme exterior heat. They are the spatial price required to safely operate at extreme altitude. These hidden levels house electrical substations, heavy-duty pumps, massive water tanks, and complex air handling units. If you follow a hypothetical resident's ordinary morning, the scale of this hidden dependency becomes clear. When water reaches a luxury apartment on a high floor, it has already been forcefully pushed up through multiple engineered pressure zones. Pumps must carefully divide the extreme height so the plumbing systems do not catastrophically rupture under the weight of the water. The entire building must be intelligently divided into manageable operational sectors. When conditioned air cools a restaurant, it relies on heavy air handling equipment, treating the atmosphere just out of sight. Control systems must continuously monitor these flows to ensure stability across the entire structure. The entire illusion of effortless luxury depends on these systems remaining completely unnoticed. But keeping the visible building alive requires an enormous flow of physical resources. The tower's water system supplies an average of approximately 946,000 liters every single day. Its peak electrical demand is listed at approximately 36 megawatts. That is a peak demand figure, not a constant consumption rate, but it illustrates the sheer mechanical force required to sustain the environment. Burj Khalifa is not simply a tall object standing in the desert. It is an occupied building permanently wrapped around a towering industrial machine. The building's most successful systems disappear from human attention precisely because they work so well. But that invisibility should actually be deeply unsettling. It means the tower can never casually pause its operations. The visible luxury depends entirely on the hidden machinery located hundreds of meters above the street. And that entire vertical machine ultimately depends on a defensive war being fought far below the ground. Move beneath the polished lobby. The environment down here is intensely hostile. Published project material describes a groundwater environment with chloride concentrations reaching up to approximately 4.5%. Sulfate concentrations were reported reaching up to approximately 0.6%. Internet rumors often use these corrosive conditions to claim the building is actively sinking or that the concrete raft is cracking. Allowing the viewer to expect a hidden structural mistake is an easy narrative trick, but that expectation is exactly what the evidence disproves. The corrosive ground was not an error the engineers forgot. It was an enemy they designed against from the very beginning. Durability was established as a primary design concern long before the first pour. Engineers knew the soil chemistry would aggressively attack standard construction materials. The foundation response required a highly sophisticated, layered defensive strategy to ensure long-term structural stability. This defense included low permeability concrete, specifically mixed to resist chemical attack. The engineers incorporated fly ash and silica fume into the structural design to reduce permeability. This chemical mixture significantly increases the long-term durability of the concrete. They utilized extremely low water-to-cement ratios to create a dense, impenetrable mass. Protective waterproofing measures were installed to carefully separate the concrete from the aggressive chemistry of the surrounding soil. There is absolutely no evidence that corrosion has penetrated this massive foundation. But that engineered defense does not eliminate the maintenance responsibility. It simply changes the nature of the burden. It creates a massive, buried defense network that must remain completely trusted for the entire life of the tower, because replacing a foundation is physically impossible. The environment is actively testing those defenses every single day, applying continuous hydrostatic and chemical pressure against the concrete. Below ground, materials can be protected through immense physical mass and chemical redundancy. But hundreds of meters above ground, access becomes the defining problem. Consider an illustrative maintenance scenario, not a reported Burj Khalifa failure. Imagine that a specialized exterior component hundreds of meters above ground requires inspection or replacement. This could be a weather sensor, a minor facade element, a protective seal, or an aviation warning light. In a normal low-rise building, replacing a small exterior part is an ordinary afternoon task. But when the worksite is shifted half a kilometer into the sky, the logistics multiply exponentially. First, the exact nature of the problem must be confirmed remotely using sensors or visual inspections. Then, physical access must be meticulously planned. Weather patterns and high-altitude wind conditions completely dictate exactly when exterior work is permitted. Workers and specialized tools must be transported vertically through an occupied building, requiring careful coordination with the internal elevator networks. The working area may need temporary control to isolate the mechanical operation from luxury spaces nearby. If the component requires replacement, a custom part must be matched perfectly, certified for extreme altitude, and staged for installation. The procurement process alone requires specialized supply chains capable of delivering exact architectural matches. The physical repair must be executed safely while crews are suspended in a moving cradle, navigating the intense heat and the sheer vertical drop. Following installation, the structural and technical integrity of the repair must be rigorously tested. Finally, the new component must match the surrounding surface visually, ensuring absolutely no aesthetic disruption. What happens to the price of a simple repair when the worksite is half a kilometer above the delivery entrance? The tension here does not come from the threat of a spectacular building collapse. It comes from turning a minor technical adjustment into a highly coordinated, multi-stage vertical operation. The repair itself is technically difficult and inherently expensive. But for a global icon, technical success alone is never enough. The work must also completely disappear. An ordinary building is allowed to age naturally. It is allowed to show scaffolding around a main entrance. It is permitted to display temporary cosmetic repairs or tolerate minor visual inconsistencies across its facade. A global icon operates under a completely different expectation. Burj Khalifa's image is not just architectural, it is deeply economic. The tower must continuously accommodate luxury hospitality, premium corporate occupancy, and high-volume observation experiences simultaneously. Its premium address value, its global media visibility, and its central role in anchoring Dubai's wider brand identity depend heavily on uninterrupted visual perfection. The entire building must project an aura of effortless triumph over the elements. Every visitor and investor expects the building to reflect a specific standard of flawless wealth. Because of this immense pressure, every single maintenance intervention carries a double burden. First, it must fully restore the underlying technical performance of the system. Second, it must fiercely protect the perception of effortlessness. The tower must be repaired without ever appearing to need repair. It must be upgraded without appearing obsolete, cleaned without appearing dirty, and inspected without ever appearing vulnerable. This dual requirement transforms standard building maintenance into a permanent operation of image management. This is the part I find most revealing. The massive hidden machinery is not only preserving the physical building, it is preserving the idea that the building requires almost no machinery at all. This creates an exhausting, relentless standard for the crews managing the infrastructure. They are fighting friction, weather, and time, while being contractually obligated to remain nearly invisible. This relentless cycle of inspection and cosmetic correction is what keeps the brand alive. The stakes are incredibly high when a single visible flaw can be photographed by thousands of daily tourists. Maintaining this illusion of perfection requires an astonishing amount of perfectly choreographed labor. But eventually, invisibility cannot be achieved simply by repairing only the original systems. As technology advances and operational expectations rise, the building must begin changing generations. To understand this transition, we must clearly distinguish between three different levels of operational commitment. Maintenance is the ongoing daily effort of keeping existing equipment functioning smoothly. Repair is the localized act of correcting a specific defect or responding to a sudden failure. Modernization is an entirely different operational category. It requires replacing or upgrading core technology, control systems, performance monitoring, and operational interfaces as industry standards naturally evolve over a decade of continuous use. Every smart building in the world undergoes this process to integrate with modern digital standards. The sheer scale of the structure simply makes the process much more visible. The Otis elevator program, extending for another 10 years of service, is simply the clearest public example of this shift. These massive upgrades require careful financial planning and flawless operational execution. But before assuming this proves the building is inherently flawed, we must look at the strongest piece of counter-evidence. Burj Khalifa has officially achieved LEED Platinum certification under the version 4.1 Operations and Maintenance for Existing Buildings rating system. This achievement must not be ignored or hidden. A building can be well-maintained, technically sophisticated, internationally recognized for its operational management, and still require an enormous lifecycle commitment. The environmental certification does not erase the massive technical complexity of the tower. It actually demonstrates that the complexity is being actively and aggressively managed at the highest possible level by dedicated engineering teams. The original mechanical systems are smoothly handing over operational control to newer, more efficient networks. The tower may not be deteriorating into failure. It may be transitioning into something much more expensive to fully understand. It has entered a permanent sequence of overlapping, generational upgrades that will continue as long as the building stands. Technical condition alone cannot determine whether the tower was a mistake. The ultimate answer depends entirely on which economic ledger is being read. No reliable public source used in this investigation provides a complete, audited annual maintenance cost for Burj Khalifa as a standalone asset. There is no independent profit and loss account available for public review. Therefore, this investigation will not pretend to calculate an invented annual bill. Instead, we must look at two separate economic ledgers. Ledger 1 represents the visible operating burden. This includes the massive facade cleaning operation and its specialized access equipment. It includes the vertical transportation, the ongoing modernization programs, and the heavy pumps driving the water systems. It must account for the air handling units, the peak electrical demand, the complex control systems, and the fire and life safety infrastructure. It also covers the daily inspections, the specialist labor, the buried corrosion protection, the procurement of custom components, and the constant logistical management of disruption. Ledger 2 represents the immense symbolic and commercial value the tower produces. This includes the premium residences, the corporate offices, and the luxury hotel operations. It includes the revenue from the restaurants and the high-volume observation experiences. It factors in global tourism, the immense premium address value, the continuous media visibility, and its central role in anchoring the surrounding downtown Dubai brand. Finally, it includes its immeasurable contribution to Dubai's international image. We cannot simply assume that the expenses of Ledger 1 mathematically exceed the revenues and indirect value of Ledger 2. The real financial tension comes from the impossibility of separating them. The tower's incredibly high maintenance obligation may exist precisely because the building creates its value by remaining an immaculate icon. If the tower's value depends heavily on appearing timeless, how much capital can be spent preventing time from becoming visible? The strongest economic question is not whether Burj Khalifa costs money to maintain. Every major building in the world does. Has Burj Khalifa created so much symbolic value that Dubai can never afford to let it look ordinary? The tower may simply be too valuable to neglect, and far too demanding to ever treat like an ordinary building. The viral sewage truck story offered a very easy form of humiliation. It suggested that one absurd planning error exposed the complete emptiness of Dubai's luxury image. The investigated reality is far more complicated and far more demanding. Burj Khalifa contains a highly sophisticated structural system and aggressively engineered durability defenses. It relies on extensive mechanical infrastructure, specialized facade access, and continuously monitored vertical transportation. It is undergoing major modernization programs and operates under a formal, certified operations and maintenance management system. The building does not appear to be surviving through engineering incompetence or desperate workarounds. It survives through continuous, highly organized human and mechanical intervention. That continuous intervention is the actual maintenance trap. This is not because it proves that Burj Khalifa should never have been built. It is a trap because once it was built, the massive obligation to preserve its performance and image became almost impossible to reverse. The tower's maintenance problem is not that its systems are failing. It is that none of them are allowed to fail. Its financial problem is not that maintenance creates no value. It is that the tower's value may depend on maintenance never becoming visible. Burj Khalifa proved that a building could successfully rise 828 meters above Dubai. The unfinished experiment is whether an icon built to defeat age can ever be allowed to look its age. The content in this video is strictly for educational, informational, and analytical purposes. Our investigation relies entirely on publicly available engineering documentation, official operational reports, and recognized sustainability certifications. While we strive to accurately examine complex lifecycle engineering principles and architectural maintenance, this independent analysis does not constitute an audited financial assessment, official appraisal, or a direct representation of the property's management, developers, or ownership. What do you believe is a justifiable maintenance cost for preserving a monumental global icon? Is there a limit to the price of architectural perfection? We want to hear your thoughts, so please share your unique perspectives in the comments below. If you found this deep dive fascinating, make sure to subscribe to Dubai Viral. Join our community as we continue to investigate and showcase the massive, hidden engineering systems that work tirelessly behind the scenes to keep this extraordinary city running.